Hi there. I hope this is not going to get too boring for you, this video. There's going to be a fair amount of talking taking place, and so I know that a lot of viewers would rather see action rather than words. But anyway, after I finished the cross slide for the lime hand shaper, I decided I needed a rest and I needed to do something different because I'd been so long on the cross slide I was pretty fed up with it. So I was looking in Nick Carter's site, and there was an article in there by a fellow by the name Brooke, I believe. Can't remember his first name. And it was in relation to setting up a thread cutting system on the Taig Lathe. And it's pretty simple, and I studied it for some time, and then after I'd thought about it, I thought, well, I could do it that way, the way it's described in the Nick Carter's site, but I wanted to incorporate it so that it wouldn't be so large. And in the article he has a plate attached to the headstock here, an aluminium plate that's looks a bit to be about that long, and it comes out across the back, which was no good for my setup. So I took a look at my setup and decided that this big aluminium block that I have the lathe bed set on, I could incorporate that instead of having a plate there by putting two linear bearings in each end and using a 3/8 shaft, just an ordinary drill rod, because it's not going to get a lot of use and it's pretty accurate in sizing. So that's what I did. And of course the first problem I had was putting two holes in at each end for these linear bearings, and of course at the time I wasn't thinking about it, and I took it over to the mill, and of course it has to be sitting up. It's about 6 inches high. By the time that was set down on the mill, I had no room for drilling or boring the holes, and it meant tipping it up end for end, doing one hole then the other end, and so I sat down and thought about it for a while, and then I thought to myself, well, if I put this block on the table in the situation it is now, it's lower, and if I mill a slot right the way through, say 3/4 inch wide and so deep, then I could still use these linear bearings. And these linear bearings were 625 on the OD. They're like a plastic kind of material with some 4 rows of bearings that revolve around in an oval situation, and so I thought, well, if I put a slot in the way in the block from the top down, I can then make up on the lathe, I can make up some little blocks with the bearings inside the blocks, and then the blocks would sit down in this big block. So I got quite excited when I thought about that, because I was thinking that I wouldn't be able to do it. So anyway, that's what I did, and because it's so deep, see, I had to get back down below the lead screw gearbox on the end here, so I had to go quite deep, and that, so what I did was, when I dropped the 3/4 blocks down, I made up a spacer block that rests on top and is kind of a nice snug fit on top of the blocks, so that lines everything up, stops it from moving, you know, up and down. So then I thought, on the original article, he had applied a 3/8 drill chuck in the end, which is quite bulky, and so I have one of these Chinese ER16s with the long shaft, the 1/2 inch shaft, and I studied that and took some dimensions from the bore of the headstock on the spindle, and took some dimensions from this ER16 unit, and decided that there was enough wall left if I machined it down. So that's what I did. I cut it off shorter, and it's about 2.5 inches in from this end. I'll take it out and see if I can show it to you. Here we go. So I'm going to have to give it a little tap to dislodge I think that's done it. Yeah. So it's a nice fit in the spindle bore. It's got to go. See, I've got a tapered plug in at the back, at the bottom. There we go. Let's see that. Yeah, there you go. So what I did was, where are we? Yeah, that's the final unit, and I machined it down. And made up a 1 degree, like a tapered dowel, 1 degree. It's about 1/2 inch long, so there's about 9 thou difference between the front and the back. So that's a nice gradual wedge, and I drilled and tapped it 840. Well, then I came across a problem where do I get a screw? I hate ordering stuff and running around looking for stuff. So I had an old Whitworth Allen bolt in my stock, and what I did was I machined it down to a fairly nice fit in the bore. That's the original bore. You see, there's only about 40 thou wall on each side. So that's what I did, and I got myself a bit of a 10. Well, I keep on saying 10. Maybe it's a 1032, 1040. I don't know. just cut the head off and drilled and tapped the Whitworth bolt and screwed it in with a bit of Loctite. So that solved that problem. So the collet holder is already recessed at the bottom end, so nothing interferes with the collet itself when you're tightening stuff in there. So I thought that was a nice feature, because it's not so cumbersome. So yeah. So anyway, that works a treat. It spreads the wedged dowel just nicely inside the spindle bore. So that was that, and I decided that I could use a 3/8 collet, and any threads that, or any studding that I need as a master for threading different pitches. It's just really the pitches that are most important. It doesn't really matter what the diameter of the thread is, in a sense. So I just thought, well, any studding that I have that is suitable for a certain thread, I can always machine it down so that it fits in the 3/8 collet. So that's kind of worked out really nice. And that collet, I think I paid about $18 for it. Dirt cheap. So some of the Chinese stuff is okay. Anyway, so then what happened after I'd got that, I decided that at this end, in the article, he has a bar that fits on this 3/8 shaft at this end, and he's got a split collet to lock it onto the shaft, and they really work very well. I've done quite a few of those on projects that I've made, particularly George Thomas's versatile dividing head, and they're just excellent. So he has a bar at this end, and on his one the bar comes through here from the plate and a bush, and it comes through and it attaches to the side, to the front side of the carriage, and it's all exposed. So that was another nice feature that I figured would be an improvement, is the fact that I've got everything underneath and it's protected from a lot of dirt and swarf and what have you. And so anyway, this bar comes up, and at the top end it meshes with a particular nut that is suitable for the thread that you have in the collet. And so my idea was that in being attached to this end here, he couldn't move it. That was a fixed position. It was exposed to all the dirt and swarf, and then when you're doing little short threads, the bar is sticking right away out here, and of course that wasn't suitable for me because I've got this unit so close to the headstock, the drive unit. So what I decided to do was I'm going to make an identical bar that fits on this end, but I'm going to leave it locked, because what I've done, I'll show you this fixture that I have underneath here. I hope you can see that. Yeah, I think you can. I'll take the camera down and show you anyway. But I've put my fixture underneath the carriage, and it's all underneath the bed, and it's attached to the bar underneath. So I put another split nut there, locking nut, another split locking nut, which I can undo, and I can move this shaft, or I can move the carriage along. Where are we? I've got a little. I'll show you this when I take it off. Just need to undo it enough. Now if I put my hand on, you see, it's moving now. Okay, and so I can have just the bar, enough rod sticking out to attach to the bar and use on the master thread on the spindle, but I can now move the carriage along to where I want it and lock it, and so all I have is a 3/8 bar, which is completely out of the way, so to speak. It's not sticking out here. So I figured that that's another improvement on the situation. And it doesn't take any force at all to just lock up that bar. It won't move once those split clamps are nipped up. So now I can move the carriage along, and the bar is just sticking out so far here, and that should be an improvement in my estimation. On top of that, this 3/8 bar it looks to be in line with the spindle, the center line of the spindle, whereas with his one he has the bar over an angle. So I think this way it's more confined into a smaller area. One of the problems that I did come up against was the base plate that comes with this lathe, or all Taig lathes, the little extruded base, when they screw it in, there's 3 screws underneath, goes in through the bottom of the extrusion and into the lead, I presume, and it's so damn tight I couldn't remove it. I even used one of those hammer things that spring loaded, and that wouldn't even budge the 3 screws. So what I had to do was I had to take the headstock off, take it off the aluminium block, and set it up, the whole thing up on its edge here. And I took the carriage off. Everything was taken off except this, and I managed to set it up on the mill and line it up square and machine the 2 edges of the little plate that clamps, that screws, that holds the base down, because it wasn't in line with my aluminium block. So if I put a slot in square with one face and then put this back on, the plate is not in line with the edge of the bed. So I had to machine that square off of the edges of the bed, and in doing that I cleaned the edges up, and then I took the block, and when I was putting the slot in for the bearings, I also put milled a recess in the top, the same width as the bed plate, so that it's a good fit in there. And so now everything is square with this block. The block is parallel, the base is parallel, the edge is all parallel. If I hadn't have done that, then in assembling this unit, it might have been loose at this end and gradually get tighter and tighter as I move out. That's gone through. Yeah. So that was another problem that I had to rectify in the process. Okay, I'll take this unit off now. Let's see, and I'll show you what I've done. It took a little bit of calculations and thought process. These adjustable parallels, they came in real handy. I was able to get dimensions as I gradually built up the bracket here, so that everything was in line with the shaft, with the 3/8 shaft, and I was able to get the dimensions that I needed to finally set up the main block that fits the shaft. So let's see, we'll take this off. I'll put this in here first. When I take the shaft out, I put a dowel in there so that the split clamp doesn't get disorientated. Okay. So the saddle already had a nice T-slot in the bottom of it, so I was lucky there. And what I'll do is I just undo this, a little washer, and just a brass, hexagon brass nut. And here's a T-nut I made up. I've got several of them here. I made them up as spares. I use that, and that's a 1024 bit of studding that I cut off and used. And this is the main unit. Okay, can you see that? So I used I just used parts that I had hanging around. You know, over the years you get lots and lots of accumulation of bits and pieces, and so I just used flathead screws, you know, just what I had. So they're counterbored quite deep. They would have looked nicer if they were just below the surface there, but it doesn't matter. The dowel is 3/8, and this is a 632 screw. I don't want to take it out. It's just a just a bit of brass. And what I did was, let's see, I got the block, and I drilled the hole. I drilled and reamed the hole a 1/4 inch for the split collet, for the split clamp, and I left the head on it, so it pushed in right the way through as one bush, and then I put a little bit of Loctite on the head at the end here, and left it for, I don't know, half an hour, and then I was able to turn the block over in the vise, and then I spotted it, located it on the mill, and spotted it, and then brought it over here, put it in my 4-jaw. What I did was I used a center drill first of all on the mill, and I spotted it and went down with the center drill right down into the body of the center drill, which gives you a pretty good datum point for dialing in on the lathe. And then I put it in the 4-jaw, and then I just drilled it and bored it and to size, and at the same time it formed the groove, the small groove on the split clamp. So then after I'd done that, I just heated it up a little bit, didn't take much, and removed it as one piece, and then I put it in the collet here, and I parted it off with a 40 thou blade, and so that's how I did that. Worked okay. So had a little bit of a mishap here. I'm doing it on the drill press and using a drill bit, and the bloody thing, you know. So that doesn't look very nice, but it doesn't matter. It works. Nobody's going to see it unless they take it off. So I'll put it back on, and then I'll take the camera and show you from underneath, or from this end, what it looks like, and give you an idea. What I did for location, I could have used dowels, but I figured, well, you know, if it's all going together, I can just use keys, male and female, and that's good enough to keep everything square. Actually, they're quite good for size, so there's no slop there at all. Even on this part here, it's quite a good fit. So there we go there. Put that on. Okay. It doesn't take long to set it up. If you want to take it off, you can do. That's a good fit. I don't do it up too tight. It's not gonna move. So there we go there. I wonder if I can put the camera down here and you can see what I'm doing. Let's see. Yeah, I can bring everything up this end.